Let me begin with a disclaimer. These concepts are not going to be considered vital in your studies. However, as far as a gee whiz factor goes, this is a lot of fun. Let's talk about two states of matter they don't generally teach in school. This is plasma and the Bose-Einstein condensate. So we know all about solids, liquids, and gases. We know that in a solid form, matter is in tightly bound form where the molecules are connected to each other with bonds, but they're still vibrating. As we add heat energy, those bonds start breaking so that your atoms start moving smoothly round and past each other. As we add more heat energy, those atoms actually start breaking away from each other and filling up all available space and room. What happens if you raise the temperature to super high levels, between 1,000 degrees Celsius and 1,000,000,000 degrees Celsius? Will everything be just a gas? Well, it kind of depends. If the gas is made up of particles which carry an electric charge, but the entire gas as a whole has no electric charge, and if the density is not too high, we can end up with the fourth state of matter, which is plasma. Now, this is not the blood plasma, but this is a different type of plasma. I like this graph because it helps us to see that when the density is high and the temperature is low, we have our solids, liquids, and gases. These objects are too cool and too dense for plasma to exist. But as the density decreases and as the temperature increases, we have a lot of matter that becomes plasma. Let's look at some examples. Here are some places where plasma is found. In flames, light, the aurora, neon lights, stars. In fact, cool thing, since stars make up 99% of the total matter in the universe, therefore by definition 99% of everything that exists is in its plasma state. So if you're ever asked in what state of matter is most matter found, you can simply answer plasma. The sun is an example of a star in its plasma state. Clouds of gas and dust around stars are in their plasma state. So now we know all about four states of matter. We know about plasmas, which is only for low-density ionized gases, but if we take heat energy away, we return the plasmas into their gaseous state. And if we continue taking heat energy away, bonds begin forming, going through condensation and giving us liquids. And if we continue taking heat energy away, those bonds become tighter and tighter formed until you have a solid. But now what happens if you continue to lower the temperature way, way, way down to a bare 100 nanodegrees above absolute zero? Will everything still just be a frozen solid? Well, not necessarily. In 1924, two scientists, Albert Einstein and Satyendra Bose, predicted a fifth state of matter, which would occur at very low temperatures. Now, they didn't have the technology in order to be able to test this theory. It was not until fairly recently, in 1995, Wolfgang Ketterl and his team of graduate students discovered this fifth state of matter for the very first time. Now, this fifth state of matter is called the Bose-Einstein condensate, and what they had to do in order to discover this is remarkable. They had to invent some new ways of cooling, using laser cooling and magnetic cooling and vacuum cooling, in order to bring the atoms down to just those few nanodegrees above absolute zero. So, in a Bose-Einstein condensate, atoms no longer bounce around as individuals. If you'll recall, in our solids, we have our atoms that are tightly bound together, but each one is vibrating independently of all the others. In a Bose-Einstein condensate, they must all act exactly the same way, and you can no longer tell them apart. So in behavior, they go from looking like a bunch of individual particles to looking like a single, or behaving like a single particle. Now, here's a picture that a computer took of the Bose-Einstein condensation. This big peak right here happens when all the atoms act exactly the same way. Now, we cannot see the Bose-Einstein condensation with our eyes because the atoms are too small. And if you'll recall, we talked about the fact that in order for us to be able to see anything, the particle has to be large enough so that a light wave can hit it and bounce off. Atoms are so small that they are smaller than the smallest wavelengths. So we cannot see them, but the computers can show us what the behavior of the atoms are. So here are some other computer images of the Bose-Einstein condensate. Now, to really understand the Bose-Einstein condensation, you need to know quantum physics. So when you go to your parents today and they'll say, "What did you learn today?" You can tell them, "Oh, not much. We were just studying some quantum physics." In 2002, Ketterl and 2 other scientists received the highest award in science for discovering this Bose-Einstein condensate, the Nobel Prize. And now you know about the 5 states of matter, all the way from the very, very highest temperatures to the very lowest temperatures. And remember, when we're talking about temperature, we're talking about the kinetic energy.